All right, so we're going to talk about the periodic trends and how they work. All right, so I think on the paper that I gave you, if you go ahead and first indicate what the trend is, what's going on, that's going to be your first step. So if you notice, I have the arrows where it says atomic radius will increase as you go down a group, but it will decrease as you go across a period. Okay, for ionization, it decreases down a group, it increases across a period. Electron affinity and electronegativity and ionization energy all have the same trend. So you won't have I think, a hard time remembering that, because all three of these are the same. Decreases down and increases across. The only one that's different is the atomic radius and the ionic radius. Okay, for the explanation of radius and how it works, I want you to think about it as the size of the atom, and when it goes down the group, it's getting bigger because you're adding more energy levels. So you're adding more rings. That makes the atom bigger. That's a reason why it will increase or get bigger as it goes down a group. On the other hand, when it's going across a period, the question is, why is it decreasing? Why is it getting smaller? And the reason why it's getting smaller, okay, what I wrote down is, here's the number of protons as you go across a period. So this would represent lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so those are the elements that you find in the second period right here. Okay, so as you go across the second period, there's its atomic number. That means that the protons are increasing. There's more. What happens is that the protons are like magnets. So the stronger this magnet is, when you have more protons, the more it's going to pull on these electrons. So here it is at 3 protons. At 4 protons, it's more protons, slightly bigger, so it's going to pull a little bit more, and then the atom starts shrinking. Here's at 5 protons, and you're going to notice now it's smaller because it's pulling on these electrons even more. As it goes and increases, 6 protons, 7, you're going to notice that it's shrinking and shrinking. And then once again, that's because that increase in protons is actually pulling these electrons closer to the middle. Again, it's like a magnet. It becomes stronger, so it's pulling those a lot further in, causing the atom to shrink. And that's why the size of the atom decreases as you go across a period. Okay, for ionization energy, that's the energy needed to remove an electron. So you're pulling an electron. Let's see how this happens. Okay, for the trend, as you go down a group, you're going to notice that according to what we wrote, the trend is that it's going to decrease. You're going to need less energy going down a group. Here's the reason why. If you recall, I told you that the protons are like this magnet. So the closer it is to the middle, the more it has a pull on it. It's a greater pull because it's so much closer. So it would take you more energy to pull something that's close to the nucleus. As it gets further, it gets weaker, so it's easier to pull it away from the electron from the atom because it's not as close to the nucleus. And here it's much further, so easier to pull, and here it's so much further, easier to pull. Think of someone, when you tell a child, be careful, stranger danger, because someone might take you. If there's a parent that's close by, that's watching their child, it's harder for anyone to go and take their child away because they're a lot closer. They're near their vision. Now, if someone starts going further and further away from their parents, it's easier for someone to come and take them. Okay, so kind of the same sort of a weird concept like that. But the closer they are, the more energy it takes you to take them away. But the further they are, it's not as difficult to take it away. The same concept applies here. So remember that the atom is getting smaller when you go across a period. So if it's smaller, the nucleus is closer to these electrons. So that means it's going to be harder to take those electrons away versus the ones at the very beginning of the period. So that means that the energy required to remove that electron is going to be more. So ionization energy increases as you go across a period because that means that those electrons are closer to the nucleus. Okay, for electron affinity, it's the energy that when an electron is added, or how much it wants to accept electrons. So I want you to look at the periodic trend. So the periodic trend is that there's more of a need or want to accept electrons as you go across a period. The reason that happens is that if you notice the valence electrons increase across a period, they get greedier. Rather than saying I have enough electrons closer to being perfect 8, they say I don't want to give these up, I want to accept them so I too can be 8 valence electrons. So they become greedier going across a period, and they want to accept electrons a lot more. That's why the ones closer to the left hand side want to give electrons, and the ones on the right hand side want to take electrons. But that's pretty much the reasoning. They want to get to that 8 valence electrons. Okay, so as you go down the group, the reasoning behind that it decreases is because now the proton or the electrons that are on the outer rings are further away from the nucleus. So there's a stronger pull on the electrons that are closer. You want to keep those, but not as strong of a pull as you go further down. And here's your electron. So now it's further from your nucleus, and there's not that great of a pull. So that's why that energy is gonna decrease. Last one for electronegativity. What happens with electronegativity? That one, as we indicated here, that's going to be your attraction for electrons and creating bonds. Okay, as you go down a group, again, the same concept with the pull between the protons or the nucleus and the electron or the valence electrons on the outer ring. So you're going to hold on to these electrons a lot closer, or a lot stronger when they're closer to the nucleus. There's not a great hold when it comes further. That's why it is decreasing, or that attraction for the electrons is decreasing because it's further. So the magnet is not as strong. As you go across a period, you're going to want the electrons a lot more. And once again, the same concept applies. It's that it's closer to the nucleus, so therefore you're holding on to these electrons a lot stronger. So what happens as you go to the left side of the periodic table, these valence electrons are a lot further to the nucleus, and therefore it is not as strong. That want or need for or attraction for electrons is not as strong.